Hi, this is Laura Alford. This is a video on vector indexing and matrix indexing in Matlab. Alright, as briefly went over in lecture by me, but not very well because my technology all failed, this is vector indexing. So in vector indexing, there you have a vector of elements, and each of them has a number inside, which is the index, and we've shown it visually here. So this is the first element, the second one, number 3, number 4, number 5 here. Okay. To select the elements, you use parentheses, so not the square brackets. That's when you make matrices and vectors. When you want to select the elements, you use parentheses here. So when you go to select an element, you can either do it one by one using just the index number, or you can use matrix, or you can use this colon to select a range of stuff. So here's what I'm talking about. So here's an example. So we have a vector x, and when we select elements, right now we're saying I want element 1, 2, and 4. Because we want more than one, we have to put them in square brackets here. And so visually this is shown here where you've got, I'm just totally using my mouse to point things out here. So we've got the first element here is the first one called, so the 3 goes here, and then the 7 goes here. And then now we go for the fourth element right there, and we put that here, 8 goes down here. So we want 1, 2, 3 total elements. So we have a 3-element row vector down here for our answer. But we've selected the first element, the second element, and the fourth element out of x here. So just to show some other examples, if you want just the first element, you do x parentheses 1. If you say you wanted the fourth one, that's this one. And then if you say you wanted a whole bunch of them, you can do, give me the third element, and then the first one, and the second one, and another second one, and the fifth one here, and the third one, and the first one again. You can do this, and this is what it gives you. So the order is really important in here. So first it says, give me the third element first. So that's 2, and it puts it down here first. Then it takes the first element, puts that one next, and then the second one, which is 7, another second one, so another 7, and then the fifth element, which is another 3, goes down here, and then third element, which is a 2, so it goes here, and the first element, which is 3, and it goes here. So Matlab can do this. Okay, for a range, you can do things like this. You can do 1, 2, 3. That will give you the first 3 elements, 1, 2, 3, right in a row. You can do, if you do step, the first element, and then the step, and then the end, this will give you this one. So it says start with the first element, start with the first element, and then go every 2 elements to then you get to until you get to the element 3. So this pulls out just 3 and 2 here. You can also do, if you want to go, start with the first element, go every 3 elements up to the 5th element. That gives you this one. So this one pulls out the first element, element number 1, and then element number 4 here. Okay. All right. Okay. So things to watch out for are things like x. Everything actually turns it into a column vector. So watch out for that one. Okay. Another complicated example here. You can use this to do things. So you can first take the range of 1, 2, 3 elements, and then you can go to start at the 5th element, and then go backwards. Go back by 1, and go all the way down to the first element. Do this, and now we get this one. So the first 3 elements, 3, 7, 2, are right here. And then it says start with the 5th element and go backwards. Then we get 3, 8, 2, 7, 3. 3, 8, 2, 7, 3 down here. All right, that is vector indexing. Going on to matrix indexing. So in a matrix, each of the elements has the sequential index, and it goes by column first. Now this is really easy to forget. I do it all the time, so try not to be me. All right, so here are the indices. First is number 1, and then 2 goes down, and then it keeps going down the column until it runs out, and then it goes to the top of the next column. 3, and then 4, and then it goes down here and comes up, then it goes 5, and then 6. So this is how it works. This is what's known as column major order. Okay? So for just quick examples here, down here, I want to do, I can start with what's here. So this is one example. So if you put in X and you say, give me the first element, and then the second, and then the fourth, it will go elements 1, and then 2, and then 4, and put them in a row vector for it, because that's what form this is a row vector. So you get 2, 0, 4 down here in the pink. All right. Other examples of what you can do, so if you take 2, 4, 6, this gives you the bottom row. If you do 1, 3, 5, this gives you the top row. Again, these numbers only work for this particular matrix. If you have a different size matrix, then the element indices mean different elements. Okay. Dang it. Sorry about that. Okay. Going back to this one again, another really complicated poll here, data poll. So it's kind of 2, 4, 6, 6, 4 here. Gives you multiple ones like this. So that's actually sort of what we're talking about here on this next slide. So you can do this and you can get really complicated. It's so complicated we made the letters bigger. All right, so X. So do 2, 4, 6. This kind of, you go to Taco Bell, right, and say everybody wants all these different meal numbers and things. All right, so say you get a whole bunch of orders. You can put it all in, and you say, aha, give me this. And so Matlab will make this for you. So this visualization I think is kind of nice. It shows you exactly which elements you are taking from X, and then it shows you down here the order in which they were put in. Okay. Say, continuing with the restaurant example, say you say I want 1 of everything. So that's 1 to 6 here. This is put it in a row vector. So now we get 1 of everything, but notice the order that it goes in. Again, it goes column major first. So it shows 2, 0, and then 5, 8, and then 2, 3. Okay. You can also combine this. If you want to do more than one thing, you can put it in the matrix stuff with the square brackets here. So say you want 1 of everything and then an extra number 2. That would be 2, 0, 5, 8, 2, 3. So the original matrix plus another element 2, which happens to be 0 in this case. Right? So that is matrix indexing in order to read from a matrix. Now to write to a matrix, you are going to use the assignment operator, which is the equal sign. And you have to make sure that, so the left-hand side says which elements you're going to change, and then the right-hand side says what are you going to put into it. Okay, so for example, let's first say y is equal to x 1 through 4. So y is equal to the first 4 elements in x. Okay. So y is now a row vector 2, 0, 5, 8. To sort of look at that, it shows down here exactly where all this is coming from. Okay, so say we start with that. We can now go in and say, let's change the first 2 elements of y to be equal to the third and fourth elements of x. Okay, watch this one. Okay, all right, so right here, y. First 2 elements is what we're going to change, and into those elements we are going to put the third and fourth elements of x. So teal goes into green, and it's a 1-to-1 map in exactly the order that you choose. Okay, so now we've got the 2 and 0 here, and elements 1 and 2 on y changed to be 5 and 8. So now we have 5, 8, 5, 8. All right, more examples, because I think just seeing examples is the best way to kind of understand how this works. Like when do you use the square brackets and when you don't, kind of thing. Okay, so I want to do this, and we'll do, I can't find my cursor. Hang on, sorry. Okay, y, first and third elements, and I want to replace those with the first and sixth elements in x. All right, so here we go. Again, sort of showing which elements are going where here. So there's this one. You can also do something like this if you need to replace some elements or a bunch of elements with just an actual number, like say 0, you can do this. So again, it shows you exactly which elements you're going to change on the left-hand side and then what you're going to put into it on the right-hand side. Okay. Big note, the number of elements that you are specifying on the left-hand side has to match the number of elements that you are telling it what to look for in the right-hand side. So always got to match it up. Okay. All right, so let's move on. Okay, so here is an exercise that you can try. The question is to replace all the elements in the first row of this particular matrix with 0. There's lots of different ways to do it. Try and come up with one. If you can come up with one, then keep thinking about it and try and get some other options that you can do things. All right, so let's take a look at some different ways that you could do this. So first of all, you could set each individual element equal to 0. That is totally fine. It's a lot of typing though. A different way is basically the same approach, but in one line. So you select X and you tell it to go get elements 1, 4, and 7, all in one line. Another way to do it is to recognize that there's a difference of a jump of 3, because there's 3 rows in this matrix. You can say go from element 1 to 7 and go every third element and set it equal to 0. Here's one more example. If you have make it be a little bit more flexible, you can use something called end. The end is a special word in Matlab, and it gives the last index of the array. So it's really actually quite nice when you are trying to make a program or a piece of code work for a matrix that doesn't have a specific size. So in our case, end means element 9. So it would go all the way up until it hit 9 here. Okay, but there is a much more intuitive way to do this, and that is called row and column indexing. And this is the usual way of indexing into a matrix in Matlab. All right, so instead of doing it by element, we're going to specify the rows and the columns. Now keep in mind, you have to tell it which row first and then the column, and you separate it by a comma, okay? So just get in the habit, keep it in mind. Practice will definitely help. Okay, so let's do some examples here. Get down here. So here is a matrix that we're starting with X. And right now, if you give it just 2 numbers, you say go to the second row and go to the third column and get that element. And in this case, it's element 4. All right, so here is a bunch more examples. So we can go in and we say, give me row 1 and 3, and give me columns 1 and 2 here. All right, so it's for the first row and the third row, and then first column and second column. And so wherever those match up, you can kind of picture this in your mind. And wherever those match up, it says, okay, get those elements and take those and put them into a new matrix. And the matrix here matches up with the number of rows and columns that you put up here when you pull things out of X. Okay, So to sort of illustrate this, if we keep this the same, but we add in, say, go get also column 4, now we've got 2 rows that we've specified, but then 3 columns. So our answer becomes a true a matrix with 2 rows and 3 columns here. If you want to get all of a column, you say, give me all the rows in a certain column. So in this case, it says, give me all of column 2. So all the rows in this column 2. If you want to get everything in a row, then you say, give it 1 row, and then do the colon, so it says, give me everything that's in all the columns. So this here says, give me all of the 3rd row here. Okay? That kind of stuff I think comes in really handy. One more example here, just using the range stuff. So if you want to do the 2nd and the 3rd row, I'm going to say start at row 1 and go start at column 1 and go every other column until you get to 4. That will give this. So now we've got the 2nd and 3rd rows, and then the 1st column and the 3rd column, which is how this 1, 2, 4 came out. So after that, so this gives you then a 2 by 2 matrix here. All right. So this is okay. So row column indexing here. You can specify the order of it. The order is really important, and then you can do more than one. So here's the example that we've got sort of set up. So this says, give me all of the rows, and then do column 3, followed by column 2, followed by column 4. All right. So again, so all of the rows, but column 3, column 2, column 4. So column 3 gets put first. So it's the 6, 4, 8. That now becomes the new column 1, and then column 2. So that's 2, 2, 6 goes next, and then column 4, which is column, and then 3, 3, 1. So that's how it creates it on the sort of on the answer side. Okay. So again, the order really matters. So here's a couple more examples on the cursor here. All right. So if we say give me rows 2 and 3, and then do start at column 4, go backwards, get each one, and go all the way to the first row, to the first column here. Do this. All right. Okay. So I've been thinking about this one for a minute. So this says so again, in terms of what you're going to make in the end, it's 2 rows. It's row 2 and 3, so it's 2 rows, and then all the columns, but you're going backwards, so it's 4 columns. You're going to have a 2 by 4 matrix. But again, the order makes a difference. So the rows are going in order, but the columns are backwards. So you've got 3, 1 goes first, and then 4, 8, and then 2, 6, and then 7, 4. So that's that example. And then showing how you can order multiple stuff. Say for some reason we wanted to duplicate columns. So we say we're going to duplicate rows. So we got rows 2 and 3, and then we're going to say another row 2 and another row 2. Okay, so this takes out. All right. So it's working with the same data, but the end result is different. So we have what we started with, which was rows 2 and 3 with the backwards column, and then we've said do another row 2 with the columns going backwards. So that's 3, 4, 2, 7, and then another 3, 4, 2, 7. Okay, so all of this is just sort of trying to get you used to manipulating data and thinking of how all of this stuff works. Okay, so lots of examples. So here's an example, an exercise that you can do on your own. All right, so try and take this and try and double the value of each element in the first row of this matrix, and then create a new matrix using only the odd numbered columns from the original, and then set all of the corner elements of the matrix to all zeros. And if you can try and do this in a way that doesn't specifically use the column numbers, like maybe try and use the end function, I think that's a good habit to get into. All right, so here are some solutions to how you would do this. So first one, to double each value of an element in the first row. So double means 2 times the row, right? 2 times the value. And so if you just take x1 means get everything one, row 1, and then the colon means get everything in that row. So that's the whole row. That's that. And then you can save that back into the original matrix because they match. So that's why you got x parentheses 1 here. Get here. So we're going to do the calculation here, but then store it back in to where it came from. Okay. So create a new matrix from only the odd numbered columns. This here gives you so this is all the rows, right? So we're working with columns. This is start at the first one, go every other one to the end. So this is, if you ever see something about how to do odd numbered columns, this is what you need to do. And new matrix, this is y. So y equals this new thing. Okay. Set the corner elements of a matrix to all 0. So whatever matrix that you are working with here, so start with x, and the corners are just 1 and end and 1 and end. So first row, last row. Sorry. First row, last row, first column, last column, no matter what size matrix that is. Set all of that equal to 0. So these are good tools you can come back and use later. All right, so to leave you with this, here's a challenge. This is not an easy thing. This is actually inspired by Dr. Jewett's brother, who was working on some Matlab code for his robotics project, and was inspired by real world stuff here. So look at this matrix and try and write a single line of code that will reverse the columns in a matrix, no matter how big the matrix is. And if you're kind of stuck, go back a few slides and look at some of the examples that we did. And then the next challenge is to write a single line of code that can shift, oh my gosh, yes, I know, thank you Google Drive, to write a single line of code to shift all of the columns one to the left and take the leftmost one and then wrap it back around to the right, okay? All right, good luck. I think you can do it. If you get stuck, come in office hours and talk to us.